and let's select that body. Select to true and SV cell data. Now I'm just going to make here a select data type object. Don't worry about that. Sorry. And sorry. And let's see what happens here. So we're gonna put a break here and let's run the code. Maybe I should put it here. Or we can go with this. So we're gonna go from the start here. So when we run this, at this instance, the part doc is equated to the currently active model. And since it's a part, it will pass. In this instance, we got all the bodies. So now we have an array of 3 of those bodies. So this will loop 3 times. Now we set the body to vBodies I. And there, it selected this one. So that's the first body. When we loop through again and we select again, there's the second body. And when we loop through again and select, it will get the third body. Now you understand what's going on here. It got all, now we have an array of these 3 bodies, right? And now we can do with these bodies whatever we like, pretty much. We have it, we can extract data from them, how many faces they have, get the faces of the body, get the underlying surfaces. So what we're going to do next, we're gonna just comment this out. We are going to get all the faces of each body. Now we're gonna write this out again for I equals L bound v bodies to U bound v bodies next I, and we are going to set the SV body equal to v bodies of I. Now, in order for us to get the holes, so these holes in this body, we need to loop through all the faces of this body, right? And let's get all the faces of the body. So the same way that we got all the bodies, we can get all the faces, right? So we first need a vFaces variant, and we need to say vFaces equals svBody.getFaces, right? So if you were to go into the API help, and go into the part doc, go to the members, go to the get bodies, and the return is it returns array of bodies, and we have an iBody interface. Now if we were to go to the iBody interface, we have the get faces method. Now the getFaces method returns an array of faces on the body. And once we get all the faces, we can loop through them, get the underlying surface. So once we have a face here, we can get the underlying surface. So we have get surface get surface method here, then we get the underlying surface. And once we have the underlying surface, we can check what kind of a surface is it. Is it a torus? Is it a sphere? Is it a cylinder? Is it, you understand? So each of these faces has an underlying surface which tells us, is it planar? Is it cylindrical? Is it a torus? What kind of an underlying surface we're working with. Now, so once we have these faces, like I said, we need, now let's make a variable of type face, dim sv face as solidworks.face2, and for j equals l bound v faces to u bound v faces next j. We're doing a for loop inside of a for loop. And let's set the SV face equal to the V faces of j, sorry. And once we have the face, we need the underlying surface, right? To check what kind of a face is it. So let's make a dim SV surface as solidworks.surface, and let's set the SV surface equal to the SV face.get surface. Now let's check if there is anything in the API that could help us. Now, if we were to go to the API help and for the iSurface type, try and find something that could potentially help us. Here we have methods that are named is blending, is cone, is cylinder, is offset, is parametric. If we were to actually go to our model and check our body, we see that each face here has a surface type. Basically, this is a plane, this is a plane, this is a cylinder. So all the holes here have surfaces that are cylinders, and that could help us. So what we're going to do is see what this method actually returns. So the method returns true, so it's a Boolean value. It returns a system Boolean, so a Boolean value, true or false. And it says true if the surface is a cylinder, false if it is not. So if we were to go and say, is this face, so is the surface of this underlying surface of this face, is it a plane? No. Is it a cylinder? No. Is it a plane? Yes. Is it a cylinder? No. So it would return to us a negative value for the Boolean. But for this one, it would return true. It wouldn't return false. It would return true. So we can weed out the cylinders on this piece. So what we're going to do is, okay, say, well, if SV surface dot is cylinder, then else, let's say pass here, and if the surface is a cylinder, do something, right? And what we're going to do here is actually go through each face with selection. So don't worry about this stuff that I'm going to write right now. Just bear with me here. So SV entity as solidworks.entity, then SV cell data as solidworks.select data, and what we're going to do here is say, okay, set SV entity equals SV face, and SV entity dot select for true SV cell data, and let's see what happens. Now let's run the code and see what happens. So the first thing that happens, it loops through the bodies, but inside of the loop it sets the body to the current body that it grabbed. We don't know in this vBodies array what body is first, what body is last. We know that we got all the bodies, but what body we got, we don't know. Then we got all the faces from those bodies, and now we're looping through each and every individual face. The first face that it looped through, it wasn't a cylinder. The second face also wasn't a cylinder. The third face also wasn't a cylinder. The fourth face, and so on. So we got to the next body. So it probably did what happened earlier. It grabbed this body, then it will probably grab this body, and then it will grab this body, and then we will have some true values because it will come to the cylindrical the cylindrical faces, right? So let's go here. It probably won't select anything because it's on that second body. Now we're getting to the last body, so the body of interest basically, and it will get to a cylinder. There it is. So it got to the first cylindrical face, and if we did a select method, and if we were to go, here it is. It selected the first cylindrical surface, and we will go through again. So let's go here and see it selected another one. Then it passed. Let's see which one it selected next. Okay, we have this one now. So it has 1, 2, 3, 4 more faces to select. There. Another one, and another one, and it ended. So if we were to go to the model now, you would see that it selected all the cylindrical faces, because this face was a plane, so it wasn't a cylinder. It returned false, and that's why it only selected these cylindrical faces. So at this stage we can do some more stuff. So since we have a method, we have a way of weeding out all the cylindrical surfaces, what we can do next is maybe write out the diameter. Let's go to the API here and see if anything could help us. So we know that it's a cylinder, and here are some public properties, and it says cylinder params. So that seems interesting. Let's enter it. And here we have an array of doubles describing the parameters of the cylindrical surface. Now, as it says, it returns an array of 7 doubles with origin X, origin Y, origin Z, axis X, axis Y, axis Z, and radius. This radius is interesting. So how would we grab this radius with this property? Let's see here. So it says value equals instance of cylinder params. Instance dot cylinder params. So we need a surface. An instance of a surface. So let's do this. SV surface dot cylinder params. And since the value is a system object or an object, so the value should be an array of doubles describing the parameters of the cylindrical surface. We need an array to hold in those values. So let's declare one